No, with NASA, it's like you get the name, but you don't really learn anything. So I haven't applied to NASA yet. I might, but okay.
Do it. Go to space. Be what's in space from the Martian. Matt Damon.
Oh god.
Except he was the
He was a botanist?
Yeah,
Why? I didn't want to.
Oh.
They wanted to like have it do it.
I'm ruining it.
Does he have to be ejected into space?
I'm ruining it.
Have you not seen it?
No.
You wanted to see it.
Oh, sure, we can see it later. Okay.
You guys can sing the song if you want.
Video on?
What? Yeah, the video's
Yeah,
on.
we're gonna do it.
That's how you start the video.
Start the video.
It's already on.
Apply to us.
Oh.
No.
Here we go.
Are you guys in it?
This is Charles.
Stand up.
Stand up, Charles.
And
And it's his 20th birthday.
how long do I have to stand?
Until we're done.
Yeah.
Happy
birthday to you. Happy birthday to you. Happy birthday, dear Charles. Happy birthday to you.
Yay. I just passed it. Okay. I'll sign it later. No, I'll sign it.
You get a free 100 on the exam.
Oh, yeah.
Okay. Let's start with partial fractions. Do you guys all understand partial fractions?
There's a question on the homework that I did a bunch of times.
And then you understand them now?
No, and I didn't get it right once.
Okay.
Would you like both? What number is it?
Number 2.
Oh,
Because like it's just like I keep messing up on algebra.
Yeah, algebra is important.
Honestly, Daniel, nothing in this unit is good or easy, so just whatever.
It's just
Is that a
So-
17, Daniel?
What?
Is that a 17 on top?
Yeah.
Okay.
So this is from your Dino slides, but I'm just teaching you guys how to break up a fraction or break it up into fractions. So this can be broken into a over. Well, what's the first thing we need to do?
Factor.
Yeah. So what would it be for this?
X plus 2, X plus 1.
Yeah, x plus 1 times x plus 2. Okay. Once you do that, you know how many fractions essentially you'll need. So this one we have two different parentheses or quantities being multiplied. So we can put a over x plus 1 plus b over x plus 2. Okay. And then there are two methods to solving it. One is multiplying them out to get the same denominator again. So then you have terms that correlate. So then this would be a times x plus 2 plus b times x plus 1 all over, so it'd be x squared plus 3x. It's better to put it in parentheses. X plus 1 times x plus 2. On the top we'll have ax plus 2a plus b x plus 1. Since we wanted plus b. We wanted to look like this quantity with a group having an x in it and a group without an x. So if we were to do a like grouping on that, we would have x times a plus b, and then plus a quantity 2a plus b. Did that make sense?
Yes.
So then this is equal to 10x plus 17, and then they have the same denominator. but this 10 has an x, and then this x has a plus b. That tells us that the quantities with x's, 10 is equal to a plus b. And then the 17 doesn't have any x, or x is 0 power. That's the same as 2a plus b. So 17 is equal to 2a plus b. Now you have a system of equations. You can make the first one a negative so that the b's cancel out. We'll have 17 minus 10, so that's a 7 equal to an a, and then b will be equal to a 3. Okay? Did that make sense? And then, so you can plug those back in, and your integral will be 7 over x plus 1 plus 3 over x plus 2.
So these seem pretty simple. Do they get harder?
What if there's only one thing on the
Like number
top?
2.
Like 1 here. So then 0 would be equal to 2a plus b.
It depends if it was had an X or not.
Yeah. So, like, are you saying if there was no 17?
If there's just like a 1 on top.
If there's a 1, so then the component in front of an x would be a 0 here.
Okay.
So then this would be a 0, and the 1 would relate to the numbers without any x quantity, so this would be a 1. One thing you have to know is that the top has to be 1 lower in exponential power. Otherwise, if they're equal, you need to divide them. And then there's another method. So this method will always work, but the problem with it is you can have like 4 different fractions being multiplied, so you'll have so many numbers that you'll need to match with the numbers on this side, and it'll be a lot of work. Okay? So sometimes this is not the best method to do it, and sometimes they tell you which method to use. Like sometimes they'll tell you use the Heaviside method, and if you use this method, you won't get any points. So,
I think
So
it's,
this is the normal method.
so you have to know both of the methods.
There's a high.
Yeah. And the thing about this is that this is not, don't think of this as like hard calculus. This is pretty basic algebra. Okay? And you do use this later on in differential equations. We'll see.
Thanks.
Yep. So looking at that same problem again, so we had a over x plus 1 plus b over x plus 2. So this is the method that I sort of like to use because it's a bit quicker and it uses limits to make it faster. So you have x plus 1 here, and this x plus 1 is not repeated anywhere else on this side, right? So that's why it can work. We can multiply both sides by x plus 1. Okay? When we do that, this x plus 1 in the denominator goes away. So we are left with 10x plus 17 divided by x plus 2 equal to this x plus 1 goes away. So we are left with an a. And then what we do is we have to multiply by the limit as x approaches -1. Because we're multiplying by, that would make this x plus 1 quantity 0. Okay? If we multiply here by the limit as x approaches -1, this goes to 0. So when b is being multiplied by a 0, this quantity goes away. Okay? So this entire quantity goes to 0 since it has an x plus 1 in the numerator. I can rewrite that. So it'd be b times x plus 1 divided by x plus 2. Okay? The a stays since there's nothing that will go to 0 because the x plus 1 quantity cancels out. The left side stays, but the b, it goes to 0. So we don't have to worry about it. And now we have an equation where if we plug in an x equal to a -1, we'll find the value for a. So in this case, a is equal to 10 times -1 plus 17 divided by -1 plus 2. So the denominator is a 1, and in the top we have a 7. So this is equal to a 7. And so we got the same answer. Where's the sign sheet? Okay, did everyone sign it? Okay. Did that make sense?
Yes.
So now we have a value for a. We can do, can I raise it?
Yeah.
We can repeat this exact same thing to get the value for b. What will we multiply by this time?
Plus 2.
Yep. If we multiply by an x plus 2, what does x approach? -2. So limit as x approaches -2. In the top, or in the left side, we have 10x plus 17 divided by x plus 1 now, equal to a times x plus 2 divided by x plus 1 plus b. So the left fraction goes to 0. We're left with b equal to 10 times -2 plus 17 divided by -2 plus 1. So in the top we'll have a -3 divided by -1, so it's a +3. So both methods worked. Yeah.
So let's say you had that one and it was like, let's say that one, the term was squared, it would fail then.
If this was squared here, like
Yeah,
that,
so you would have like the a x plus 1, and you would have b over x plus 1 squared, right?
yeah. So then you need to do it with the highest power.
Okay.
So if we multiplied everything by an x plus 1 squared, we would still have, or in the, yeah, let's do it with x plus 2. If this was squared, we multiplied by everything x plus squared, we would still have a b because it wouldn't have anything in the denominator, but the a would go away because it would have an x plus 2 quantity that will eventually go to 0.
Okay.
This will remain the same, just the denominator part of x plus 2 would go away. Okay? So we would be able to find the value for b. Now, if we had something with x plus 2 squared in the denominator, we would have a plus c with x plus 2.
Yeah.
So then we can't use this method again to find c. Okay? We'd find a and b, and then we need to use a different method to find c.
Okay.
Does that make sense?
Yes.
And that goes with the hybrid method.
All right. Thank you.
Yeah, like you can do this method to get rid of or to find b in our example, and then use the hybrid method by setting, say, x equal to 0 and solving for c. I'll go over that. Can't erase this. So this was a simple example. And if you guys really if you want me to explain it again, make sure you ask because you really need to understand this. So just going over how to make the fractions. Say we have x squared minus 2 all over x squared x plus 1 squared times x plus 2. So then in this we would have 3 fractions. We can set a over x plus 1 plus b over x plus 1 quantity squared plus c over x plus 2. Yes? How would you divide? If you look at the power of x, if you multiply these out, you have x cubed. And you need to make sure when you see that. So on my exam, it had it like this, and I was supposed to divide. Like, there was nothing to here. It was like this, and I was supposed to divide because it's x squared. But I didn't because I realized, well, they gave me parentheses, so I just went along with it. Yeah. So they might do that with you guys too. So
Yeah.
you need to make sure that the exponent in the denominator is greater. Because when you're running out of time, you don't really stop to think about it. You go along. No, you get some. Okay. Did this make sense though?
Yes.
Like you do 1 power lower. So if it was cubed, you have another fraction with x plus 1 quantity cubed. And then there's, okay, let's do this one.
This is a hybrid method example.
We're still, like, I'm going to show you guys again how to make the fractions.
Oh, okay.
So x plus 2 over x cubed times x plus 1 times x squared plus 2 quantity squared. So the top doesn't need to be 1 lower than the denominator. It just needs to be lower. Okay. So then first we'd have a over x plus b over x squared plus c over x cubed. Okay. Because it's x cubed, don't just leave it as 1 fraction. Plus b over x plus 1. Okay. Now here's where people make mistake. When you have x squared plus 2 inside the parentheses, you need to have 1 lower. So it would be g x plus e over x squared plus 2. Doesn't matter.
Yeah. Whatever you want.
Let's just, so I'm just going to do e plus x.
You can use it.
Yeah, like for differential equations, my teacher didn't like to use c because that's used for constant plus c or something, but it's whatever. And then we'd still have another fraction with gx plus h all over x squared plus 2 quantity squared.
I would love that for a lot of tests.
So like with this method, you can't use the first method because it would take forever.
Yes.
You need to multiply a by all of these numbers, and then everything, and then reorganize them. So the method that I would use to solve this problem is first the heaviside method to get rid of x cubed, x plus 1, and x squared plus 2 quantity squared. Okay, does that make sense? If I like, well, I'm gonna do a different example with this, but looking at this problem, if I multiplied everything by x cubed, actually, it would be an issue because then we'd have zeros. No, we wouldn't. Yeah, x cubed would work.
That's what you do, and that's why.
Yeah, I'd multiply everything by x cubed, and then as x approaches 0, this would go to 0 because it would have x in the numerator. This would go to 0. We'd be left with a c without any x's, so our quantity would equal c. This would go to 0, this would go to 0, and so would this. So then we'd have c equal to some number where we'd plug in 0 for that and these two. Okay?
And you just for each letter.
You can't, now we can't do it for b and a though. because if we multiply everything by an x, we would still have an x here in the denominator and a here, right? Then these two would be undefined.
Okay.
So if we multiplied everything by an x, it would be b over x as x approaches 0, and then that's not right. That would be between. And then what I would do is multiply everything by x squared plus 2 quantity squared.
Okay.
So then I would have still this quantity, but then this would go to 0 because we'd have an x squared plus 2 in the numerator, and all of those would go to 0. Actually, that wouldn't work. Tell me why.
What? Yeah.
Oh, because you have a x, no?
There's no way I can do a limit as x approaches a value that would make x squared plus 2 go to 0. So then you have to use a different method. There are different methods. There's the hybrid method, which
That's what we're doing now. You're explaining.
now right now I was explaining the Heaviside method in this problem, and then there's a separate part which is of the hybrid method. Okay, so we'll get to that. Do you guys understand the Heaviside method now, though?
Yes. Thank you.
Okay, let's do the hybrid method. X squared plus 2 divided by x plus 1 quantity cubed times x plus 2. So you guys should know how to make all the fractions. We have a quantity cubed here, so we would do a over x plus 1. Now I increased the fraction exponent, but I'm going to keep the same numbers, same a and stuff as in the example. So it'd be a over x plus 1 quantity cubed plus b over x plus 1 quantity squared plus c over x plus 1. Yeah, since we have no idea what they mean, it doesn't matter. We just, if I had x plus 1 cubed over here, then my c would be equal to the a in the problem. So using the Heaviside method, what do I multiply everything with?
X plus 3 quantity cubed.
So then if we do the limit as x approaches -1, the x plus 1 quantity cubed in the denominator goes away. We are left with x squared plus 2 over x plus 2. A. And all of these go away because we'd be multiplying by a 0 to all of them, with the limit as x approaches -1. So therefore, a is equal to plugging in a -1. We have -1 squared plus 2 all over -1 plus 2. That's equal to 3 over 1. What can I multiply again? Or can I erase this? The bottom part? So we have a is equal. What else can we easily find right now? The d, okay. So by multiplying everything with x plus 2, the x plus 2 here in the denominator goes away. We are left with x plus 1 quantity cubed. A, b, and c, all of their fractions go to 0 because we're doing as x approaches a -2. Okay? But we're still left with a d because the denominator went away. So therefore, d is equal to a negative 2 squared plus 2 divided by negative 2 plus 1 quantity cubed. So in the numerator, we have 8. In the denominator, we have 1. So d is equal to 8. Should be a 6.
Is it a negative point?
Yeah, it should be a negative.
Yeah, it should be negative. So negative 6. Did this make sense? So let me know when you guys have a copy of that. Good, can I erase it? So now we have the values for A and D, but we need to find B and C, okay? The only other method that I showed you guys was the first method, is by multiplying everything by the whole denominator, right? But we don't want to do that because that'll take forever. So there's something else which you could do. Yeah. Once we know the values for A and D, we can put them in. Okay, so now we have just 2 variables that we need to find. The easiest thing to do now would be to, anyone? Plug in some random numbers. The easiest random number to plug in is 0.
Why can you do that?
Because it is a valid equation. And if we plug in a 0, we would just have some numbers equal to some B plus C or something like that. So if we plug in a 0 here, we would have on the left side 2 over 1 times 2 equal to 3 plus B plus C minus 3. Do you guys see that? And then this quantity becomes a 1. These 3 actually go away. So we are left with a B plus C equal to a 1. Did that make sense? Now, the second one is harder because we don't have a number as easy as 0. So we can do 1. Okay, make this. As x equals to a 1. We plug in a 1 in the top, we'll have a 3 divided by 2 cubed, which is an 8 times 3. Okay. On the right side, we'll have a 3 over 2 cubed, which is an 8, plus B over, did I do that? Yeah, B over 4, plus C over 2, minus 6 over 4. Or minus 6 over 3. Okay. Now after this, it's just a matter of simplifying it and working with the fractions, as annoying it may be. So this is negative 6 over 3. I can rearrange that, and it'll be a minus 2, right? So this is not just me trying to simplify this. Yeah, so I can rewrite that as 1 over 8. The quickest thing, it seems, right now is to put everything to the 8 denominator. So we can make this a 2b divided by an 8. We can make that a 4c divided by an 8. And a negative 2 can be a negative 4 or negative 16 divided by an 8. Yeah.
We just multiply from that 8.
Yeah. But now we can do that. Now since they're all in the same denominator, if we multiply everything by an 8, we won't have any fractions left. Or you could have done it before. Doesn't matter. But it just depends on you trying to simplify it the way you okay. So we are left with a 1 equal to 3 plus 2b plus 4c minus a 16. So 2b plus 4c is equal to, that's a minus 2 plus 16 is a 14. And then you simplify that, we have b plus 2c is equal to 7. If we write that up here, we can subtract the equations, the b's goes away, so we are left with a c equal to a 13. I did that wrong. That should be a 7. So that's a 6. Therefore, b is equal to a minus 5.
Then you do the integral with all of them, right?
So, did that all make sense? So then we can put a b is equal to minus 5 equals to 6. And then you do the integral.
For that first one, like let's say we're doing an integral for that a, how like what would that be?
This?
Yes.
So you'd have x plus 1 to the negative 3 power.
Okay.
So then you treat this like a u.
Okay.
So then it'd be u to the minus 2 divided by negative 2.
Okay.
For this right here, you do a natural log of this du over u.
Okay.
Same for this. So do all of you guys have this copied down? So I'm going to write down the integral. So the integral of that entire quantity is equal to negative 3 halves times x plus 1 to the negative 2 power plus 5 divided by x plus 1 plus 6 times the natural log of x plus 1 minus 6 times the natural log of x plus 2 plus c. And like this became positive because it's a negative denominator divided by a negative 1. That's why this became negative. So that's just doing the integral, right? Yeah.
Where do you get the it's okay on the last one it's like minus 6 absolute value by
Oh, sorry. I forgot natural log.
oh
Do you guys all get this problem? Every single part of it. Because what? Sure. You can bring it up. Yeah. Oh, we have a lot to cover actually, but okay. What? If you understand partial fractions very well, then that's a huge accomplishment.
That's the answer.
Yeah.
Hey, why can't you try you for videos?
What? I remember.
I think they like them.
They definitely.
They love it. They love it.
The reason, what?
I was gonna say, you explain that better in the videos. Yeah.
Yeah.
It was also our second time seeing it.
Yeah. Can I erase all of this? I think it's just because I've had good teachers explain it to me. And then you kind of repeat what they've said to you. Because I learned this in high school. Okay.
You don't have to do the,
Yeah, the limits. So we have 5t squared minus t plus 9.
Which one is this?
All at once.
This is number 3. T cubed plus 9t. Okay. So what can we do with the denominator? Okay. First thing you should know is we check the top and it is one lower. Okay. It's not equal, so we don't need to divide. So we have t times t squared plus 9. Okay. Can we simplify t squared plus 9 anymore? No. Okay. So we'll have two fractions. We'll have a over t plus b x plus b over t squared plus 9. Is that where you guys might have messed up? Okay. So what method should we use? The heavy side method. Because we don't.
On the first part,
Actually, you could use either method and be
because
good
the
with it.
second part, then you have to.
Like, yeah, you could use either method, but let's just go with I like the heavy side method. Okay. So I multiply the whole thing by a t. That should be t. So we have limit as x approaches 0, 5t squared minus t plus 9 divided by t squared plus 9 equal to a. Therefore, a is equal to 9 over 9 equal to a 1. Okay. If we multiply everything by a t squared plus 9,
You can make that thing.
what do you mean?
You're going to use the heavy side method with that one, right?
Yeah.
You can't make it equal.
Oh, so then what method do we use?
Yeah.
We could do something else. The mixed one. No, it's not. So we got a is equal to what? 1? In the hybrid method, what did I tell you guys?
Oh, you plug in your x.
Because we need to do a limit as that goes to 0, as t goes to 0, so then the a term goes away. That's the essential use of it. But right now, yeah, we couldn't do that. So we know a is equal to a 1. We still have b and a c. Yeah. So we can do as t goes to 0. We get 9. We can't do that since there's a t being multiplied right here. So then we can do a t goes to 1.
So we just write t equals 1 and then plug in.
Yeah.
Okay.
So we have a 5 minus 1 plus 9 over 10 equal to 1 plus b plus c divided by 10.
where did 8 with 1 come from?
We found that using the heavy side method. That was a equal to 1, right? So this is just 10 over 10, if you think about it. In the top, we have 5 minus 1, that's a 4 plus 9, so that's 13. So 13 is equal to 10 plus b plus c. So we know b plus c is equal to a 3. Did you guys get that far? And what can we do with the t now? We can go with a -1. Okay. Instead of using a 2. Yes.
Do I have to learn?
Yeah. You use the first method.
Yeah.
You need to use this method too. Because on the test they may tell you to use the hybrid method. And then you won't get any points if you use the first method. Okay. Using t equal to a -1, which is to me is better than a 2 because it avoids multiplying big numbers. By using a -1, we have 5 plus 1 plus 9 divided by a -1 times 10. So -10. And the denominator equal to -1. So we'll just do -10 over -10. Or, yeah, -10 over 10 plus -b plus c divided by a 10.
Where'd you get the negative?
Because it's -1. This, so we can make the top quantity a -1 on this too. So since everything is over 10, we can multiply everything by a 10 to get rid of the denominator. We'll have a -15 equal to a -10 minus b plus c. So we have c minus b, or -b plus c, equal to -15 plus 10 minus 5. 2c is equal to a -2. C is equal to a -1. So then our b is equal to 4.
Negative one or one?
Yeah. So now we have values for every one of them. So we can rewrite this. As the integral of 1 over t plus 4t minus 1 divided by t squared plus 9 dt. This would give us what? 1 over t. Natural log of the actual value of t plus, you have to split it up. So we'll have a 4t over t squared plus 9 minus 1 over t squared plus 9. This top one, you can set your u equal to t squared plus 9. Du is equal to 2t, right? What? Yeah, you can bring this 4 on the outside, essentially multiply by a 2, so 4 divided by a 2. Or you can do a 2 times 2, so then that 2 will remain on the outside. On the left, what would you do? You have to factor out the 9, so you'll have a minus 1 over 9 times 1 over t divided by 3 quantity squared plus 1. Then you do the inverse tan, right? Yeah.
So why did you factor out 1.1?
I mean, the 9, you have a 9 in the denominator. It's the same. It's just like,
Yeah, so you take out a 9, so you have t squared plus 1 divided by 9, and then that's t over 3.
And then just multiply by
1/3.
1/3.
Yeah, when you do the actual integral. Yeah. Want me to do that?
You don't have to. That's just-
I got natural.
Do you guys want me to do it?
Yeah, yes, Jenny would like, well, Jenny's fault.
So we have the integral of -1/9 on the outside of 1/t/3 quantity squared plus 1 dt, or u is equal to t/3, du is equal to dt/3 times 1/3, so times the outside by a 3. So this is equal to -1/3 times the inverse tan of t/3. Let's see. Does that make sense?
Yeah.
Well, I mean, yeah, this plus all of that.
The next term, I think, is 2 natural log of t squared plus 1.
Yeah, that's what I was asking.
Oh, you're asking about this one?
Yeah,
Yeah, but it's the, no, for this one, you have du/dt.
yeah.
So it's the natural log. Is that what you said?
So it's 2 natural log t squared. Oh, there's 1 half.
Yeah, natural log
No,
of,
no, it's 2.
It's 2.
Natural log t squared plus 1.
Yeah.
It's,
so then, and then you have the limits to plug in.
it's a definition of the So,
So that last one, that -1/3 is the last rule. So.
Yeah.
Okay, what's the second term?
This term,
Okay, yeah.
it's 2 times 2t divided by t squared plus 9.
No, what is the?
Integral of it?
What's it?
Are you asking about the final integral of it?
Yeah.
So then it'd be 2 times the natural log of the denominator with the t squared plus 9.
Yeah.
Are you guys good with this?
Yeah.
Okay, and then you just do the plug in the limits, solve integral. But we should move on to series and stuff. So what's the difference between a series and a sequence?
one adds one.
Good.
Commas.
How do you know when you're supposed to prove it and you're supposed to solve?
I don't know what they're doing.
They call fractions back.
I guess.
It says prove using the
It's like that way on the test.
Integral
you're supposed
test.
to actually like call it solve. Right? And then
they
like,
say evaluate or prove. Yeah, on this they do. Okay.
They did the adding one. They, you know how like they write like a couple of terms.
Yeah,
out?
the telescoping.
But then they only did 2. How did they know to only do 2 and add those 2 together?
Because everything in the middle goes away.
So they added the post picture.
it tells them that they're
You can
only
tell me which
working-
problem and then we'll go over it too.
It's a telescoping thing.
Okay.
Yeah, I just need to go over like the. I don't know.
There, okay. One of them was the sequence objective, find whether it okay. It was 2x plus 3. Okay, I'm not gonna go over that one because that's not important. There are some tough, okay. Factorials quickly. What does n factorial mean?
Bring the exclamation point and stuff.
Yes.
You yell out the n, like n.
Oh.
Oh, that was cute.
1 times 2 times 3 times n factorial. Okay? That's what it means. 1 times 2 times 3. So if you have 2 factorial, that's equal to 1 times 2. Okay? What is 0 factorial? It's equal to a 1.
Oh, you're fine.
You just have to remember that, okay?
No, no, you're.
How in depth did they go with this? So they just gonna ask us like what 2 factorial is?
No, they'll go very, very.
No, like and with the series, right? Actually, it goes to.
So if we have a series of a sub k equal to e to the k divided by n factorial. You have to find whether, like, what happens to it, okay, whether it diverges, whether it converges to a number. So with sequences, since this is a sequence, not a series, we can do the limit as n approaches infinity of a sub n equal to the limit as n approaches infinity of e to the n divided by n factorial. Which one goes faster? The factorial always goes faster, so this one's equal to a 0. So we know that this series converges to 0.
How do you know whether the series is it the series or
When-
something we're bracket?
Yeah, the summation. No, that's the summation
Oh,
sign.
and then has a summation.
Are you
Oh,
asking?
this is a sequence.
Yeah, this is a sequence.
Okay, series.
So if you were to plug in values, you'd have e to the 1 over 1, comma, e to the 2 over 2, dot, dot, dot. Okay? A series, you'd have a summation sign in the front, so you'd be adding them, dot, dot, dot. Okay.
So one's multiplication, one's.
So
One's nothing.
series?
Oh.
Sequence is nothing. It's just listing a sequence of numbers with commas in them.
That's the sequence?
Oh.
Okay? This was a sequence.
So, why is it equal to 0?
Because once, if you have, as n approaches infinity, the sequence, the last number, they're getting smaller and smaller. Okay?
Can you do the problem with the polynomial homework?
We can look at that at the end, but there's some stuff that we can go later on, because you guys, if you guys want to say, you should know, like, this stuff. Okay. On slide 36 of mine, it says limits that arise frequently on Dino. So it probably won't be 36. This is my old notes. It's like the limit as n approaches infinity of, it has some common limits such as n approaches infinity of natural log of n divided by n, and it tells you that this is equal to a 0. Okay? You can prove this using L'Hopital's, but like those are some common limits that you guys should know. So, any questions on it? Did you find it? No? Oh,
Yeah.
okay. This formula is very important. The finite geometric series, S sub n, say, is equal to, they use k equal to 1. It's going to n of a r k minus 1. They told us this formula, and there's a proof there, but you should know this. A times 1 minus r to the n divided by 1 minus r. Okay? Eventually, it boils down to, for infinite series,
What did I say? A sub r to the k?
k minus 1. But for infinite series,
That's so long.
these are r's. Yeah. Essentially, this boils down to this formula. What the series goes to, S is equal to A over 1 minus R. Okay? And your A value is your first term. So that is actually what you essentially.
So is S sub n and S the same thing?
So what is the difference?
Yeah.
They were trying to.
What's the difference between S sub n and S?
You have to look at the proof that it's asking, but it should be the same. S, they make it equal to the main function sometimes. They make S sub n equal to a function that ends. It's like a proof, but
Not important.
yeah, just don't worry about that. When they ask what a series should sum to, that's the formula you need to know.
Okay.
And there's like different things, but something that you should know is for the R value, if the absolute value of R, so I'm trying to find an example. So if R is less than 1, it does what? Converges. If R is greater than or equal to 1, it diverges. So looking at an example, just geometric series. Well, infinite. Just go with infinite. Yeah. So if I have the example summation of k equal to 1 going to infinity of 1/2 k minus 1. Okay? This is our R value. So we have the fraction s is equal to 1 minus 1/2. If I plug in the 1 value, we'd have k minus 1. So it'd be 1/2 to 0, right? So then the first term would be 1. Because anything to x1 and 0 is equal to 1. Okay? Plus, we'd have 1/2 dot dot dot. Our first term is 1 though, so our a is equal to 1. This is equal to 1 divided by 1/2. Negative. So this goes to a, sorry, it should be a problem. So this goes to a 2, meaning the series converges to a 2. Yes?
Where do you find your R exactly? Is it?
Our R value is this fraction that changes the series.
And A is the first.
A is the first term. Okay?
R isn't so obvious.
No,
You have to manipulate it to get it. You have to manipulate it to get it to that. Yeah, the R is the ratio that is being multiplied by over time. So it makes sense. If R is less than 1, it's becoming smaller and smaller, so it converges. If the ratio that is being multiplied by 1 is, say, 5, that means it's obviously increasing and it's going to diverge. So for this one, it's not directly obvious. Let me try to. What? When they ask if this, if you know it looks like a geometric series, and then you can use this method.
Like what's geometric versus non-geometric?
Geometric is when it's like the summation of a to the r to an exponent. Like,
What's the other one?
So as long as it doesn't look crazy.
I don't know.
so we have k equal to 0. We'll get to more stuff and then you guys will see. So let's do a 2k over 3k plus 1. And then in the top it's minus a negative 1 to the k plus 1. We can break this up into 2 series. We'll have 2/3 summation of k equal to 0 as approach infinity, 2/3 of k minus 1. Should just be a k actually. Did I do that right?
What do you do with the k plus r with the
don't
You multiply the outside by it, yeah. Did that make sense? This k plus 1 is 3 times 3 to the k. So then we have both of these to the same exponent, and we have 1/3 on the outside, minus the summation of k equal to 0 infinity of a negative 1 to the k power, or k plus 1. So it's just a negative 1 divided by 3, and everything is to the k plus 1. Okay? What is our r value here? 2/3. So is that less than 1? So we know that this part converges. Okay? since it's less than 1.
You have something factored out in front of that.
1/3. Is this less than 1? Yeah. So this converges. Now, if either of them were greater than 1, we would be done, and we would say it diverges. Okay.
You have to factor out something else there because of the k plus 1.
They both have the same exponent, so we just.
Oh, okay.
So one ended up being divergent.
So then the whole thing diverges.
Okay.
So now we have to add them. So this is equal to the first, so a over 1 minus r. The first term would be what? K is equal to a 0 on this side. So that goes to a 1. So our first term would be 1/3 divided by 1 minus 2/3 minus, if we plug in a 0 here, we still have the first power so it'd be a negative 1/3 divided by 1 minus a negative 1/3. So that's equal to 1 plus 1/4. Yeah. Because this is equal to a 4/3. So that's equal to a 5/4. Yeah. Because that will be on the exam.
Yeah, I figured it
Can I erase this? The integral test that you guys just learned today, it's very, you just have to know the steps and then it works out, okay? Like, yeah, you just need to know like what's the first you do, you show that, you show that. So like this example, you have 0.555 dot dot dot. Write a given repeating decimal as a geometric series and use this to express it as a ratio of p over q of 2 integers. So we just have to find, essentially what it converges to, okay? So we can say this is like 0.555 repeating. If we were to rewrite this, we would have 0.5 plus 0.05 plus 0.005 plus dot dot dot, right? And this basic steps apply for like almost all the problems, like the ones you'll have on the exam. So this is our first value, so this is our A. What is our R? R is equal to 0.1. Okay, because if you multiply this by a 0.1, we get a 0.05. If you multiply this by a 0.1, we keep moving a decimal over and over. Okay, and then it goes on forever. Now, is R greater than 1 or less than 1? So we know it converges. So then it's equal to A over 1 minus R. So that's 0.5 divided by 1 minus 0.1. So that's 0.5 divided by 0.9, which is equal to 5 nines. So this whole repeating forever decimal goes to 5 nines. Yes?
Will these get
Or equal.
converge?
What? Say that again?
Will these get converge?
Yeah. So that shouldn't be hard, and all of them follow that same process. There's nothing different. You may have like 1.5, 1.3, 1.3, 1.3. Like the 1.3 part repeats. So you know that this is equal to starting at 1.15 plus 0.0013 plus 0.000013.
So your
Yeah.
A would be
Okay. So then,
0.0013,
what?
right? Would your A be
Yeah.
0.00?
Exactly. You start your A value here.
Okay.
So this is equal to, like, you know how we broke it into two summations?
Yeah.
At 0.0013. It's like
Oh, because of
Yeah.
1.15 is
1.15. We can just add it always to the series. So our A is equal to 0.0013. What is our R value? What do you mean? Yeah. So 0.001. 0.01. This is like 1 over 100. Okay? Because every time we're moving it 2 decimal places to the left, so we divide it by 100. So our first term is, we have 1.15 plus 13 over a 10,000. They don't, oh, we just divided by 1 minus 0.01, which is 0.0013 divided by 0.99. Yeah. No, well, we can do more. So this is 3 halves. Okay. That's 3 halves.
What's 3 now? Sorry.
1.15. Actually, it's 1.5.
Are we supposed to know that? Like just
No, they just told. So I wrote this wrong.
Oh, so it's 1.513.
So I have one more zero there. So that's 3 halves. So let's get rid of that 0. The R stays the same because we're still moving it 2 places to the left. Yeah.
so, but we have to drop a 0 for each of those point
Yeah.
3.
So yeah. If so we have 0.013 on the top. We multiply everything by 1,000, or moving the decimal place of 3. Just like simplifying it more. We have 13 over 1990, or 990. So this is equal to 3 halves plus 13 divided by 990. Does that make sense? And then this is equal to 749 divided by 495.
Did they get this complicated on the test?
They could. On the old exam that I'm going to show you guys, it's 1.2525.
So,
Are you guys good with this? And then I'll do a telescope. So just remember the formula A over 1 minus 9. And if it's an infinite series, you can use that to find whether it converges or diverges and what it goes to. So for the telescoping series, the whole idea is that everything cancels, essentially. They separate it into 2, which I don't want to show you guys. Okay. So the one they do is AN equal to 1 over n plus 1 times n plus 2. Okay. The way to solve for a and b is using partial fractions. Okay. And once you do partial fractions, you get 1 over n plus 1.
Are we combining things now?
What? This is for telescoping series.
Oh,
So they could give you this.
I don't know.
Okay. If you do partial fractions, you get terms like that,
Why did
and it's a summation. Yeah. I found a and b.
Oh, you're supposed to do a whole thing?
Yeah.
Oh,
So a is equal
Do
to
A over N plus 1? Okay.
those elements do this, right?
not really.
Um,
Wait, when do you do it?
What do they say?
yeah, that would make it difficult, right?
They could give you.
Oh, it's not.
Or they just gonna say
Okay.
A and
They do say use partial fractions. Find the summation for it.
Okay.
There you go. But that may not be a telescoping series,
Okay.
because you could get a series with geometric series and do it quicker. But because this is not a geometric series here, okay?
No, they would have a, yeah,
Geometric series are
summations.
Wait,
Fine.
so how would you get a summation from doing the partial fraction?
so this is a summations, and then you broke that summation into 2 parts. So the summation now k is equal to 1 to infinity is now of 1 over k plus 1 minus 1 over k plus 2.
But how would you know?
Do what?
How would you know to do that?
To do the partial fractions?
No, to put it in a summation.
They tell you. Yeah. It's a summation of a to the n.
Oh, there we go.
There you go. Then if we were to keeping, okay, so looking at it by plugging in the numbers, we start off with 1/2 minus 1/3. That's our first k equals 1 value. Plus k equals 2, we have a 1/3 minus 1/4 plus 1/4 minus 1/5 dot dot dot. Okay. If we keep going with that, eventually in the end we'll have, we can rewrite it as 1 over k plus 1 minus 1 over k plus 2, right?
And we get those from looking at the first compared to the second.
Yeah. So the 1/3 and the 1/4, everything crosses out. Eventually this will cross out. We'll only be left with the first and the last term, which we can rewrite as what it goes to as S of n. So S of n, which is what the series goes to, is
Why are
equal
we allowed
to,
go from A to N to S and
it's just
N? It's so confusing.
Is this
S for series,
But what is, then why are we allowed?
because they use that notation, so I'm just using
If
S
I
of n.
write A to N, I take out the point.
because like when we were doing induction problems, we had S of n, right?
Yeah. Because that's what a series like equals to S of n equal to something.
Yeah. Okay.
It's just notation. So 1/2 minus 1 over n plus 2. So if we were to do the limit as n approaches infinity, to find what the series goes to, you would get 1/2.
Why are you switching into?
Yeah, how do we know when to use K's and N's and?
Did you mean?
It doesn't really matter. I know I use n's here because I did S of n. because it's like S sub n, you use n's in it. With series signs, we generally always use k. Okay. Or you could use n's, but they're variables.
The person said something in class that she did the limit of a sub n and then turned it into s sub n. Is that just correct notation?
She turned it into S sub n?
I don't know.
She might have just forgotten to keep it the same. Okay. So do you guys get this telescoping series concept? Yes, you do partial fractions. You get two fractions. When you go through the numbers, k equals to 1, or it may start somewhere else, you're left with the first term and the last term. That's your S sub n. You do the limit as n approaches infinity, and you know that's what the series converges to. So once you add up all the numbers to infinity, you get 1/2.
We need to write a statement for this. Talk about convergence.
I don't think, it depends on the problem.
Okay.
I'm just doing something. Do you guys all get how to reindex k?
It's like you basically do the opposite of what it's asked.
You can think of it like that, or you can think of it as always adding an h. So I'll show you guys that.
My brain's got like this mouse.
Okay, we have the summation of k equals to 0 going to infinity of 2k over k plus 1. Okay, and we wanted to start at k equals to 1. There are,
It's like,
I was fixing my shoe or tying.
oh,
Okay.
We know, but it
that was like a quick one.
was so
It's
funny.
like, ah.
And I walk out super quick.
Yeah, right.
So we wanted to start at k plus 1. Okay? There are two ways you can think about it. You can think about it as trying to get k equal to 1 instead of k plus 1. Yeah.
If they start, what if they-
Start.
When you change everything to
Okay. We want to start it at k equals 1, right? So what can we add to k to get 1 on the other side? Okay? What can we add to k to get to 1 on this side? Okay?
that's answer.
Sorry, it's equal to I normally think of it like that. Okay?
Wait, so hopefully
That was k plus 1. That's what you're trying to get at, or is it really k plus 1?
Wait, let me think about it. Okay. So what can we add to k to make it equal to a 1? Okay? K right now is equal to a 0. 0 plus h is equal to 1. H is equal to a 1. Yeah, I did it wrong.
Oh, no.
Yeah, I think you equal to a 0 and then solve for, right?
Yeah. Okay. Okay. We want k equal to a 1, so what do we add it? What can we add it to? So it's 1 plus h equals to 0. H is equal to negative 1. Okay? So then we have a negative 1 value. So we have the summation of k minus h here. So that's the summation of k equals to a 1. But we subtracted, or we added a negative 1 to it. So we have to do that here. Equals to 2 times k plus a negative 1 divided by k plus a negative 1 plus 1. Did that help? So there's two ways to think about it. That's just one way. The other way is just to think about it like this is k equals to 1. Without even thinking about the math, what can I add to it to get to 1? I can add a 1 to it, right? So then I subtract a 1. Let me.
No, you're right.
Yeah.
You add a 1 to it, so then you subtract.
So this is the way they do it. Let me do it that way. We wanted k equal to 1, right? So that's that's raising it to a 1 power, or not raising to 1 power. That's increasing it by 1, right? So if we do k minus 1 equal to 0, we can get every k is equal to a 1. Okay.
Great.
This new k.
What are you trying to explain? I'm confused.
I don't want to keep on saying k equals to k minus 1, but that's essentially what it is. We substitute wherever there's a k here equal to the summation of k equal to 1 infinity of 2 k minus 1 divided by k.
So you input k minus 1 with k?
Yeah.
Oh.
Can you do it when you do the same problem, but the k starts out?
You like that, do some
Yeah.
crazy stuff.
Let's make it equal to a 4 and try to get to a negative 1.
Why not? We said crazy stuff.
Yeah,
Okay.
we're on that level.
So doing it with the method that I was thinking before, k plus h is equal to a 4. Okay. If k we want is a negative 1 plus h equals to a 4, h is equal to a 5, right?
What does this H go with? The H go?
So we replace everything with k plus h. So then it would be,
Due to the.
so if this k is equal to k plus h, okay, so we can replace this k with k minus 5. Sorry, not,
I was almost following.
we want it equal to a, what?
You're increasing your base.
Yeah, we want it equal to a negative 1.
Yes,
Okay, it's equal to a 4 right now.
right.
So if we replace k with k plus 5 equal to a 4, k is equal to a negative 1.
So that means wherever we see.
Wherever we see a k, we do k plus 5.
Yeah, slide whenever you want to.
Yeah.
It's like backwards. Whenever you want to lower the value, you increase the.
That's a way to think about it, also, but that doesn't go with the. That is essentially what I'm saying. But I'll say that too. Okay. Let me go over that method.
So we're increasing it by 5 to add 5.
Yeah.
If you want to increase the k, you subtract the difference.
Okay, so if I want to K from 5
So-
to 8, I will
Yeah.
replace everything with K minus 3.
So this is like a 4 right now, and we want k equal to a 5. If we want k equal to 5 and it's a k equal to 4 right now, we do k minus 1
Everywhere we see K.
everywhere. Okay? If we want this to go to a 3, we do k plus 1 everywhere.
Okay.
Because k plus 1 equals to a 4, then k is equal to a 3.
Okay.
How do you, will they tell you which?
Yeah.
So how do they word these problems? They just say
Re-index.
re-index.
They use, like, they say reindex, just like for the old exam to start at k equals to negative 1.
Okay.
And sometimes it's easier to do it because then you get geometric series, which then you can use the formula on.
I still don't know what a geometry series is. I'm sorry.
The geometric series is the formula, like,
Is it K or N?
that doesn't matter. You can have the k power, but then k is equal to 1 same thing. K is like placeholder.
I should remember R. Sure, K or
Wait.
K.
Wait. So that, the one we've been doing is not a geometric, but the one you just wrote is a geometric?
Yeah, that's not,
Why?
because that's not a initial value being multiplied by an r to some power. This is a series, but a geometric series has your first number being multiplied by a ratio that increases it or decreases it.
Oh, so it has the A and the R.
Yeah.
Oh.
So if we start at 2 and we're always being increasing it by a 3 times 3 times 3 times 3, right? That's a geometric series. Yeah. Or decrease. Yeah. If we're increasing it by a fraction, say by like 3 times 1/2 times 1/2, since we're decreasing it by a lower than 1 ratio, it converges.
Yeah.
If we're doing it 2 times 5 times 5, it's always going to continuously increase. So then that diverges. Did that clear stuff up?
Is there anything else?
And then there are the nth term test and stuff.
We do want to-
Sure.
We saw a video.
Yeah, the videos. All right, this will be like the last problem.
MVP right here, seeing 30 minutes extra.
Yes, thank you so much.
Yep.
Word, you paid the squad.
Oh.
Good look.
So I put up the review on Blackboard. Yeah, that should help you guys. Let me find my notes on the nth series. Always do the homework before Monday. Remember that?
Yeah.
Okay.
Yeah.
So the nth term test is used with a series for k equals 1 infinity of sum a to the k. If the limit of as n approaches infinity of a to the k does not equal 0, then we know it diverges. Okay? If it equals 0, we don't know.
It could converge or not.
Yeah.
No.
Yeah, we don't know. So we have to use maybe the integral test to do it. Yeah.
It was the last thing I think about.
I was there.
No, it was something. Maybe for
So is this an example? So this is a very common one, and you will see this a lot. Summation of 1 over k. Okay. If we do the limit as n approaches infinity, so you have n equal to 0 to infinity of 1 over n, that's equal to 0, right? So we know the test fails. If we have e to the 1 over e to the 2k, 2 divided by k, limit as n approaches infinity, okay? This is 2 divided by k, so this k goes to 0. So we have 1 over e to the 0, which is 1, which does not equal a 0, so we know it diverges. Okay? And we have to show by the nth term test. If we have summation of k plus 1 over 2k minus 1, what would that go if you do limit as n approaches infinity?
You need to break it up. Or...
Yeah. It should go to 1/2, so the limit should go to 1/2, which does not equal 0.
I need cake. Oh, no, okay, so it goes here.
Yeah.
I think it's so.
Yeah, make sure you guys know what each does. Because they're,
So if it goes to the right, you get that raise.
Yeah. Because there's other tests, you know how in geometric series, if it's less than 1, it does what? Converges, right? There's I believe it's called the p-term test or something, where if it's less than 1, it diverges.
We learned that this semester.
Yeah, next, probably. This gets like 10 times crazier, by the way. Yeah. So make sure you guys don't just skip the material, be at peace with it, and then move on.
You need to see it.
Oh. That is it, guys. I have a meeting to get to. No problem. So I will. Yeah. No, not yet.